Hello, good afternoon friends. Welcome to Unacademy, which is the largest online education platform for GATE, Computer Science and IT. Myself, Malesham Devasana. In this session, I'll be discussing about the very important topic for the exam point of view. You know that the most of the questions which have been asked from LL1 parsing in the previous year GATE questions. As you know, the bottom-up parsing questions cannot be asked from the table and grammars because they consume time in the exam. So mostly they will focus on the LL1 parsing. So in this LL1 parsing, we will be seeing about LL1 grammar and LL1 table and also LL1 parsing. Here grammar and table are very important topics for the exam point of view. And when you look at the parsing, the algorithm that we do to verify the syntax of the program, that's less important for the exam point of view. But still, we will look at all the three concepts: grammar, table and the parsing algorithm. So let's begin today's session, guys. Yeah, good evening, Sai, Sandeep. And if anybody joined late, please like the session. Yeah, Satyajit, good evening. Jackie Singh, good evening. Come on, guys. Okay, anybody is new to this channel and new to this my class, and let me introduce myself to you. That is, I have secured all year rank 119 and 210 in my BTech with self preparation. Then I have completed MTech from IIT Bombay. Then now almost I have 12 years of teaching experience. Here I am going to take TOC compiler programming. Right. If you are not aware of the crash course, in the evening a crash course, and the timings are changed, that 8:15 p.m. daily is going to, I'm going to take the TOC classes from today onwards. That is a crash course. Remember, guys, crash course on TOC is going to be from 8:15. All right, Vaibhav, good evening. And in case if you are coming to Unacademy, you know that Unacademy courses are very popular to prepare for competitive exams, and use DEVALIVE to get 10% discount if you have any doubts related to your subscription or preparation, and you can contact me anytime I will help you. And these are my usual courses, that is C, TOC compiler, and regularly I take on Unacademy, and algorithm is recently started on Unacademy to take the classes on of special. Yeah, the advantages or benefits of the plus are iconic, like you have a complete course on every subject, revision course and crash course, practice course, GATE PYQ courses, doubt clearing courses and test series. Yeah, you have many opportunities when you come to the plus are iconic. And these are the various benefits, that you have live classes and you will have weekly tests, you will have a doubt solving sessions, which are very important in plus courses. And each subject you will have many educators and many courses. That's going to be really helpful for preparation. Yeah, Jayesh, good evening. Yeah, iconic, you will have all the benefits of the plus. You will have a coach and you will have a separate study material, and you have so many other benefits too. If you're not aware of the prices, let me introduce quickly. You will have the plus very popular plans like 1.5 and 2 years plans, and you have 27,225 for 1 year. After applying DEVALIVE, you will see that price 34,650 and 39,600 for the very popular plans of plus. And iconic also we have introduced recently 1 year, 2 years, and you have 45,225, 66,600 for both 1 year and 2 years respectively. Yeah, if you are not aware of GATE aspirants group, join our group on Facebook if you are already having the social network Facebook account. And we are also having the channel for the Unacademy GATE Computer Science. You can subscribe to this Telegram channel to get daily links and updates from us. Okay, guys, we have various YouTube channels. Please share with your friends if anybody is preparing for any engineering exams. And we have a very good educators on this platform. Please try to attend these courses if you are learning or if you are preparing for any GATE exam or semester exam or any other exams. These courses are going to help you. And this is the time to begin our course, guys. Please like the session so that we can start our session now. I'm waiting for your likes. Yeah, good evening Vaishnav. Good evening Vipin. Yeah, welcome back. Let's begin. And we have started comparative design very recently. We have completed introduction, lexical analysis, and then in the syntax analysis, we have completed errors, derivation of a string, ambiguous and ambiguous, context-free grammar, left recursion, elimination. Then I can tell you why do you require to eliminate the recursion. Today we will see that, and we have done left factoring and first and follow set computation. So these are the previous classes, and if you have not attended these classes, and please watch them before coming to today's session. Yeah, let's begin today's session. That I'm going to talk about what is the top-down parser, and in that LL1 parser, and in the LL1 parser we are going to see one by one grammar, table, and then what is this parsing. Okay, let's begin with top-down parser. Good evening, Vaibhav. What is top-down parser? Basically, these top-down parsers are n number of parsers, guys. N number of parsers. Like you have LL0 and LL1 and LL2. So many parsers are there. LL3 and LL4 and so on. LLK. And when you're talking about the LL, what is that LL represent? L represent that is a left to right scan. We are going to do always left to right scanning of the tokens. And another L represent this leftmost derivation. And all these parsers, they use their own grammars. We call them as LL grammars. LL0 parser uses LL0 grammar, LL1 parser uses LL1 grammar. So every parser has certain grammars we require to understand before building a parser. So what is that grammar? We will slowly understand. And before that, this leftmost derivation parsers, those parsers who follow leftmost derivation, they don't encourage left recursive grammars. Why? That's we are going to see now. Look at, guys, if you are following this, especially LL1 parser, it is called as a predictive parser. Of course, LL2 also. Predictive parser. This can be implemented using either recursive descent or non-recursive descent. So you require to understand some points theoretically. The parsers can be implemented either recursive descent or non-recursive descent. Really, we don't require recursive descent here because we are going to see the different approach to implement. The parsers can be implemented two ways: recursive descent, non-recursive descent. Recursive descent in the sense, for each non-terminal we implement procedure, function. For each non-terminal we write theory. Practically we don't do that. For each non-terminal we write procedures like functions, modules. If there are three productions, we write three procedures. And here, non-recursive descent, we will implement a table, the table approach, table-driven approach. So we'll build a table to understand the non-recursive nature. And look at, guys, in the recursive descent approach, if I have a production like this, and you might write a procedure for S, and you might be doing something about A, something. Don't worry about what is this. And in non-recursive descent, you might have a table and you do something here. This is a table approach, and this is a procedure. And procedure, I am not showing exactly how to scan the character or token to check that. Okay, we have a separate programs to understand the recursive descent. Now, when we have these parsers, the top-down parser, you can implement either recursive or non-recursive approach. Top-down parser. Now, the LL1 parser also, you can build two ways. Here, non-recursive is by default. By default, non-recursive descent. This is by default approach. But you can also implement using recursive descent. You can write procedure for each non-terminal to understand. The LL1 parser is a top-down parser that can be implemented, but by default we implement using table. It is the top-down parser here, and we'll focus on few things, guys. I say top-down parser follow LMD. Top-down parser follows LMD. Then why we eliminate left recursion, guys? And why don't we eliminate right recursion? Just let's focus on that. Yes derives SA or B. Now, do you have any problem with the left recursion? Let's look at. This follows LMD. I have an input, let's say B. And I'm trying to focus on the LL1. Remember that? I'm trying to focus on LL1. Even you don't know what is LL1, but I'm trying to help you. I know I want to derive the B, but when I look at the S productions, both are giving a B. How? The S you can substitute with the B, and B is coming from both. And which one you should take? Should I take S derives SA, or should I take S derives B? Which one to take? Really, we do not know, because this has the knowledge of one lookhead only. If you have the knowledge of two lookheads, maybe you can resolve. And it is going to look at just one token. And here both are giving the small b. There is a chance to have, and again this will give you B, and there is a chance, no guarantee guys, there is a chance to enter infinite loop. That program may not terminate at all. So if you implement the parser using left recursion, your program may not halt sometimes. If we implement using left recursion, that is the reason we convert to right recursion. In case you have, let's say, A, S or B. Suppose I want to derive the B. Yes, among these two, it is clearly visible this can only derive the B, so we can proceed for the B. Now we have a choice, and it is right recursive grammar. We have no problem with this. This is the right recursive grammar. So what grammars will create a problem? When we have a left recursion, there is a chance your compiler never stops if you implement the top-down parser with the help of left recursion. So this is why we don't prefer the left recursion to implement the top-down parsers, right? So we have a technique, we have a strategy to implement LL1 parser. We will see that. How do we implement LL1 parser, guys? Let's focus on that. We have our program already, and we will scan one token by token. We will have some concept here. Look at the configuration. And we have the stack and we have table. Okay. Focus on here. Look at how many components we have. We have our program here. Maybe you have written main, and this was already divided into tokens. And this is your input pointer, let's say. And this is your table. And this is your stack. And here you will have, let's say, control, that is algorithm. If you are talking about top-down parser, let's say LL1, that is our syllabus, LL1 parser, then how do you look at this configuration? This is LL1 algorithm, also called as leftmost derivation, and this is LL1 table, and this is how we build our parser, guys. Yeah, buffer is your input. Already lexical analyzer is scanned, identified the tokens. Now we are going to scan the tokens. We don't scan characters now. Fine. Now to understand this parser, first, what is table? What is table? You have to understand. Then what is algorithm? Then that will help you to understand how the syntax can be verified. How syntax can be verified using compiler. This is the second phase of the compiler, which is syntax analysis. If you want to understand syntax analysis, you must build a table, you must build an algorithm, then compiler is second phase is implemented. So this can produce the parse tree. This can produce the parse tree. If there is any syntax error, this can produce the syntax error. Yes. Yeah, I'm going to talk about that. LL1 0. Right now you do not know, right? Just you need to look at, you need to understand. Okay, what is the difference between LL1 and LL0? We'll talk about that. We'll talk about that. So some people are worried about LL1 and LL0. Let's focus on that. LL0 grammar means it has no knowledge at all. LL1 grammar, it has the knowledge of one symbol, one token. LL2, it has the knowledge of next two tokens. Now guys, now look at, I have an input. Let's say ABC. I have an input ABC. Now in the grammar, look at here. S derives. If you have something like this, A, B, C, D, E, F. Still, this is we call as not LR0, not LL0, not LL0. Why? Because this LL0 parser has no knowledge of what is my token, what is my input, because it can't look at even one token, zero knowledge. So it says that I can't have more than one production. So how many productions it can understand? Okay, when you have only one production, okay, that is LL0 grammar. So LL0 parser only can take, every non-terminal should have only one production. If it has more than one production, it can't choose. LL0 parser has no knowledge of which one is LL0 grammar, guys. It is just like, okay, this is LL0 and you have to, this is LL0 because every non-terminal has one production. But who is not LL0? If you have S2, AR, if you have anything else, it's going to be not LL0. But these are LL0. What is LL0? Every non-terminal should have a single production, single. Doesn't matter how many non-terminals are there, right? Single production. Every non-terminal must contain a single production. Single production. Such grammar is, such CFG is LL0 because it can't choose which production to select because it has no knowledge of what is my program. It blindly chooses that, right? This is LL0 concept. Now let's come to LL1. What is LL1? When I look at, again guys, when I look at my input, I have the knowledge of one token. So I look at my program, that is A, B, C, or D, E, F. When I look at the two productions, okay, this is A, this is D, I want A. So blindly I will choose this one. So this is LL1. Then when it is not LL1, if you have S2, A, B, C, A, D, E, it doesn't understand which production gives A, B, C. Both are having A. Now I am not able to understand which one to choose because I have only the knowledge of one. So this is not LL1. I am not able to understand which one will give ABC because I have no knowledge of who is going to derive ABC. Is it clear? It can look at only one token at a time. One token at a time. One means I have one token, one look ahead. In advance, I know who is going to be next. One token. LL2 means two lookheads. Next two tokens I can understand. Next two. Look at that. S derives ABC and ADE. I can understand who is going to derive ABC now, because now I have a knowledge of two tokens. Who is going to derive AB? I can look at now. Okay, this gives ABC. It is LL2. Up to two symbols I can cross check. Up to two. Remember, no need to be exactly two. Up to two I have a knowledge who is going to derive my ABC. Yeah. So this grammar is LL2. Then what is not LL2? That is yes derives. Suppose you have ABC and ABE. Then you are in danger, because now both are giving AB. Now this is not able to understand which one will give ABC, because it can't look at the third token at all. So it is not LL2. So this is how we can understand what is LL0 and what is LL1. Clear this point? Come on, good. Please keep on liking this session, guys. And here it's about the knowledge of the next two tokens, next one token. I don't look at it. So it's easy to understand what kind of grammar it is. Anyhow, you don't know what is LL1 grammar. How can I answer it first? But still, I have compared, I have explained what is the difference between 0, 1, 2. Okay, first learn LL1, then compare. You will understand clearly. अभी तो LL1 grammar आया नहीं, तो doubt clear करना, it's not good. Okay, anybody understood? Just follow it. Okay. Now, anyhow, you might be understood that LL1, LL0, LL2, still we will follow many things. Now, this is what we are going to do. What we do? We store LL1 grammar inside. LL1 grammar is stored inside the table. And then we use the table to understand our given program with the help of an algorithm. So how to do that? Okay, let's focus on our LL1 parser, guys. LL1 parser is predictive parser. This is by default, but you can also implement using recursive descent. By default, it is a table approach. We use the table to implement some data structure, and this is the procedure oriented. We write procedures, programs for each production, procedure oriented. And top-down parser, no doubt. This follows definitely LMD. And guys, this is not enough. It uses one special grammar. Which grammar? It uses LL1 grammar. So you should know what is LL1 grammar. It uses LL1 grammar and it stores LL1 grammar inside the LL1 table. Inside table, and it uses stack table to understand our program, to understand the program with the help of leftmost derivation. It can produce the syntax error if you have any. All right, let's talk about this LL1 parser. The LL1 parser uses which grammar? LL1 grammar. तो पहले LL1 grammar समझना है आपको. Order is very, very important, guys. First, you require LL1 grammar. When you understand LL1 grammar, then you can build LL1 table. When you build LL1 table, then we can go for LL1 algorithm to understand our program. So this is about the compiler. The compiler has the algorithm table. The grammar is already there in the table. Let's move to the grammar. What is this LL1 grammar? LL1 grammar is anybody, guys? What is LL1 grammar? It is actually context-free grammar only. But it is unambiguous CFG, and it is non-left recursive. You can't have a left recursion in the grammar. If you have a left recursion, it is not LL1. Non-left recursive CFG, and it is left factored. Everybody, these are the most important points to understand what is LL1 grammar. What is LL1 grammar? It should be context-free grammar, it should be unambiguous, it should be non-left recursive, it is left factored. But writing LL1 grammar is not easy. There are two topics in LL1 grammar. One is how to write LL1 grammar. That is useful for semester exams. How to write LL1 grammar. And second, how to identify LL1 grammar. For the exam point of view, second is very important. This is important for exam point of view. Both are different questions. Remember, how to write LL1 grammar is different from how to identify LL1 grammar. And no doubt, both are having its own concepts. Let's begin. First, how do you write LL1 grammar? If you want to build LL1 parser, you must write LL1 grammar. But theoretically, this is not possible. Practically, you need to change many times to get LL1 grammar. Okay. And we need to take the help of some practical to understand how to write. First, what you do, the step one, take any grammar first. But this grammar you have written as per your requirement. What do you do? And first, understand how to write unambiguous. And now you must convert to unambiguous. If you can't convert, you can't write grammar. Remember that. There is no algorithm to convert unambiguous CFG. Remember that. Unless you don't have unambiguous, you can't write anything. So take any CFG and convert to unambiguous grammar. But there is no algorithm. No algorithm to write that. You must understand how to. No algorithm exists in general to convert from arbitrary CFG to unambiguous CFG. So somebody has to understand how to write unambiguous context-free grammar. Then only you will succeed how to write LL1 grammar. And step 3, you must do that. You must eliminate left recursion so that convert to non-left recursive grammar. Here you can apply algorithm. Elimination of left recursion. You can do that. Now you can do. You can do on any algorithm, but we will do on unambiguous. Elimination of left recursion algorithm exists. To do that. And step 4, we will apply left factoring. Apply the algorithm left factoring. Algo exists. Now algo exists that is going to work on unambiguous grammars only. Now you will get left factored grammar. Left factored grammar. So now this is called as LL1 grammar. It's not easy to write LL1 grammar, as you must be careful. Are you writing ambiguous, unambiguous? If you write ambiguous, definitely you are going to fail. You are going to fail to write LL1 grammar. Everybody, this is a big story. How do you write LL1 grammar? But in the GATE exam or any competitive exam, they don't ask you to write LL1 grammar. They ask you to identify which of the following is LL1. Which of the following is LL1. So we have how to identify LL1 grammar rather than how to write LL1 grammar. And really it's going to be difficult. How do you identify right now? I can't explain now. By having the knowledge of few points, I can't explain, guys. Is that easy to check them? Is that easy to check them? It's not easy to check unambiguous, ambiguous. It is not easy to check left recursive, not left recursive. Right? We have some concepts to identify LL1 grammar that we do very slowly. Okay, don't worry about how to identify now. That is our last topic in this session, guys. Once you know about the table, once you know about the algorithm table, then I will help you how to identify. Right now, just ignore. We will do end of this class. How to identify. Right now, please don't worry about it. Okay, let's move. So you must understand how to construct the table, and this table can help you how to identify LL1 grammar also. I'm going to explain that. Guys, before implementing the table, you can say directly it is not LL1. Why? Because there is a left recursion. Can you see that? Can you see that there is a left recursion? This is the left recursion. So directly you can say it is not LL1 grammar. Directly. But some people implement the table, then they will understand, because theory is not always easy. So some people will have a habit of constructing the table first. But table, we are doing LL1 table, but after constructing the table only you will know whether it is LL1 table or not. So what is the approach? Step 1. In the previous class we have compute first set for every non-terminal. For each non-terminal. What is that? Like first of S. What is the first of S, guys? Open parenthesis and A. And what is the first of L? L again is S. S is already computed. Same. Now step 2. Do you have any null production? If we have any epsilon in the any first set, if epsilon belongs to first of any non-terminal, any non-terminal, then any non-terminal X, then you have to compute follow of X. But it's not required now. Here not required because there is no epsilon in any first set. There is no epsilon in any first set. So now we will go for step 3. What is the step 3? Table. What is the table? That is LL1 table, LL1 parsing table. How it looks like? There are rows and columns. And there are 2 non-terminals. So there are 2 rows. And how many terminals, guys? Open parenthesis, closed parenthesis, and a special. So this is our table. This is our table, guys. This is our table. Now how to make the entries? S and L, and we have open parenthesis and then closed parenthesis A and dollar. So LL1 table size nothing but the number of non-terminals are the number of rows and number of terminals including dollar. Don't include epsilon. Number of terminals including dollar are the columns. Right? This is our size of LL1 table. Yeah. And please respond, guys. If you interact well, then I will discuss very well. Remember that. Otherwise, I need to ignore. And now, guys, S comma open parenthesis. Look at that. I'm going to look at S comma open parenthesis. This combination. What is going to have there? I'm going to add a production S arrow L. Why I'm adding this one? Because this is responsible to give the open parenthesis as the first symbol. Why I'm not writing S derives A? Because that is responsible to give A as the first terminal. Whoever is responsible the column as the first symbol, then that production will be added. And remember, in S row only S productions comes. Never comes another non-terminal production. Next one S comma A. Which production is responsible to give A as the terminal, A as the first symbol? That is S derives A. Now similarly, L comma open parenthesis, L comma open parenthesis, there are two, L and S. Who will give open parenthesis, guys? As the first one, both will give, guys. LS, after some time this is SS, and from S you will get L, and you will have both. That is, one is L derives LS, other also gives that open parenthesis. Yeah, everyone, come on. Now this is LL1 table. Now dollar is not at all required. Dollar is required only when you compute the follow set. Only when you compute the follow set. Now why do you require dollar? Do you require dollar for this grammar? Really not required. Really not required, because it's very special. Basically, why people uses the dollar? Guys, when we are writing any program, do you know the program always ends with dollar, because how the compiler knows that end of the program is occurred, right? We are scanning in your tokens, sequence of tokens you are scanning, but how do you know that that program end is occurred? Because otherwise garbage values will be there. So this is the special one, end terminal. It will help us to stop compiling or to stop verifying the syntax. So dollar is, yeah, dollar is end terminal. Dollar is end terminal. So you require dollar when somebody is not there. Somebody is not there right now. Please don't create the doubts. These doubts can be clarified when you are doing LL1 parsing. But that is our last topic. That is our last topic. Now your focus is on how to construct the table, not why you use the dollar, now why you use the stack, how to use the tag. Please don't ask such questions now. I'm going to talk about that as the last topic. In LL1 parsing, you ask these questions again. Now, what is the problem? Yes. Okay. For L, what is the problem with L? And I'm talking about clearly, L has two productions. And I'm asking that who is responsible to derive the open? Guys, you are keeping in the first of L open parenthesis. It means L has a production to derive that terminal, that token. Then who is, which production of L is responsible? Which production of L is responsible to derive? Both, because from here you will get open parenthesis, from here also you will get open parenthesis. That is what I am talking about. Both are responsible, because this L also gets S after some time, and that S already has open parenthesis. So here you are going to write two productions, because two productions are giving. In case S derives, suppose you have A or AB. So what do? S on A, you have to give both productions. Both, because both are responsible to give that A. That is the reason first of S you will have A inside. Then who has derived A as the first terminal? Both productions are giving A as the first. And this grammar is not going to be LL1. The reason is, whenever my input, whenever my program is A, you are not having a clarity. This is not LL1, because if I want to derive A, you have two productions. You are not clear which production to choose it, right? This is multiple productions in the same cell. Multiple entries are there. This is going to be not LL1 concept. Here, guys, this is LL1 table. Up to pehli example hai na? Out of examples aayegi, doubts are, please write your doubts on the paper and look at after 2-3 examples your doubts will be clarified or not, right? Don't pause immediately. Okay, wait. Now is this LL1 grammar? मैं तो LL1 table construct किया, लेकिन ये LL1 table नहीं है guys. क्यों? Because you have multiple productions. Can you see that? This choice leads you. It is the given grammar. This is the given grammar is not LL1. How do you know that? This is how you can identify LL1 or not. This is a one method, guys. For the given grammar, consult the table. If you see more than one production in any cell, that grammar is not LL1. So note, if any entry or any cell of table has more than one production, multiple entries, we call that as a multiple entries. This is called as multiple entries in the same cell. Multiple entries we have. Then given grammar, we conclude given CFG is not LL1. We are trying to construct LL1 table, but this is not going to allow you constructing LL1 parser further. Everybody, come on, quick. First example. Let's go for the second example to start. Okay, quick. Now, what is the first technique? First off every non-terminal, guys. Quick. We don't have much time. First off S. आपको कंप्यूट करना आना चाहिए, guys. Small a and small b and epsilon small c. Do you get that, everybody? And आपको नहीं आता तो करना पड़ेगा, आपको प्रैक्टिस करना ही पड़ेगा. How do you get that? पहले small a, when you substitute epsilon here, then capital B also there without capital A. Yeah. Who is that, यार? कुछ भी बोल रहा है. Where is the small a entries? Why do you get small a multiple entry? Do you get that? L comma A. Did I miss that? Yes, I forgot to give an entry. Sorry, guys. L comma A, I forgot to give an entry. Okay. L comma A missing. Guys, let's fill up that. You will get again same. You will get again same. I stopped it because I failed to make LL1 table because of the grammar. So that is also there exactly. But already you got a reason. It was not LL1 grammar, so I didn't look at that. Every combination you have to make an entry. So we got another one, L comma A also, we got multiple entries. Yes. Okay, now let's practice. Let's practice very quickly. I forgot to make an entry. Now, and you must be good at computing, guys. If you don't know, please practice that. A comma epsilon. Everybody, first of B comma epsilon. Now this is step 1. Because of this, you must compute follow set for S. Because of epsilon, can you see that epsilon? If you don't have epsilon, don't compute follow set. Wherever you have epsilon, for that non-terminal only, you compute follow of A. Otherwise, don't compute. In the previous example, there was no epsilon in any first set. We have not computed follow set at all. Follow set is required only when you have the epsilon. Now, follow of S in the grammar, just $, and follow of A. And you look at, guys, what is the follow of A? Look at here, and follow of A means first of capital B, that is a small b, and B is epsilon, so you will depend on follow of S, that is $. And what is the follow of B? Very quick. And follow of A, no need to compute, guys, this is the same. Don't compute again follow of A. And follow of B here and here. There is no need to compute because follow of B is follow of B. This is required. Follow of S is just $. Yeah. So I assume that you can compute this first and follow set by practicing it. Now, guys, and somebody's asked, sir, why do you require the $? Look at, guys, somehow you are trying to do something here. Let me help. Sometimes you are doing something like, ASB. If S derives epsilon, then you must go to who is after S. Otherwise, how do I know who is my next token? A is matched. Now I want the next is either B or C, doesn't matter. And I'm pointing at B right now. I'm pointing at B. Now how do I know my derivation is giving B next or not? If the S derives epsilon, then you must compute the follow set. Look at follow set. Do you have a B? If the first set contain epsilon, then there is a chance follow set contain B. That means B is possible. because from S there is nothing, it means after S somebody might come. So this follow set is required only when the first of S derives epsilon. Otherwise the first of S definitely gives something. So this is the reason why you require to compute the follow offset. Now why do you require the dollar? If nobody there, like suppose you have AS, then definitely after S we assume that dollar is there at the end. In the algorithm you will understand why do we use the dollar. Okay, follow set is required because when the something is not possible from the non-terminal, then something might be possible after the non-terminal. Yes. Okay, let's move on. Now table. What is the table? Quick. What is the table? We have three non-terminals. So fill up S, A, B. And how many columns we have? That depends on how many terminals we have. How many you have? Small a and small b and small c and dollar. Epsilon please don't maintain. Nobody can see the epsilon practically. That's only for the theory, guys. Okay, we have, this is the table size, 3 cross 4, 3 rows and 4 columns. Okay, now we have to make entries. And guys, first look at why S derives A possible. Why S derives A as the first symbol? Because of the C or because of AB? Because of AB. So I can just write AB. No need to write S derives AB. Just write RHS of the production. Just write RHS. Because C never derives small a. Everybody? This one. Now, why S derives a small b? Again, same reason. From capital AB only. From capital AB. Because how? S derives AB. When you put A is epsilon, then S derives capital B. And capital B is derived small b capital B. When A derives epsilon. So small b also possible with the same production. Same production, guys. Same production. Okay. And who is responsible to derive? Who is responsible to derive? That is C. Don't look at epsilon now. And only C. Sometimes, guys, AB also might be possible. You should be very careful. C तो दिख रहा है, but कभी-कभी A से भी C आ रहा है, suppose. Then capital AB is also reason because C is possible there. So be careful. Look at all the possibilities. Now only one possibility, that is a C production. That is a C production. Now don't look at now epsilon. Look at AA. Out of these two productions, who gives small a as the first terminal? Yes, the AA production. And who gives the B on B? Who gives small b as the first terminal? BB. So we will write BB. And now we have a job. Epsilons, guys. Now focus only on epsilon. Only on epsilon. Yes, comma, dollar. What production I should give? It means which production gives epsilon. Don't make an entry S derives epsilon. Wrong, guys. Don't make S derives epsilon. Make which production gives epsilon. This AB is nothing but epsilon. So you are going to make entry AB. AB on dollar. And A comma B, who gives epsilon? Yes, this gives. So we will write A on B and A on dollar. A on B epsilon and A on dollar epsilon. And B comma dollar, that is epsilon. Look at carefully how to make an entry. So this table you can also build by writing whole production. But guys, S row means S productions only. Means all S productions only. So no confusion at all. Just you can write RHS. RHS only you can write. No need to write LHS. It can save the space. It can save the space. So this is LL1 table, because the given grammar is LL1 grammar. Every entry has at most one production. Guys, every entry has at most one production, means the given grammar is LL1. Given grammar is LL1. Now I can say that given grammar is LL1. By looking at the table, I can answer it. every entry has at most one, either no production or one production. But if you have more than one production in any entry, then that is not LL1. Now guys, look at this example. Now same, first off, yes, you compute. Same example or different? Same or different? Any change in both? Yes, there is a change. Yeah. First off, as quick guys, small a and small b epsilon, and first off capital A and small a epsilon. Small c is not there now. B comma epsilon. Now all of them require follow set because everybody has the epsilon. So follow set required dollar, and follow of capital A. You know that first of B that comes as a small b and dollar. Yeah, did I miss anything? Just cross check. And follow of capital B. It's the same and it's S, so that's a dollar. Yeah, somebody has a dot. Let's go back. Let's go back. Why do you have epsilon on AB? तो समझ लो यार, समझ लो. Why do you have epsilon? See, the A comma B, that means suppose you are trying to derive something. मेरा इनपुट बी है, अभी कैसे समझ में आएगा आपको? सिंटैक्स वेरिफिकेशन में समझ में आएगा ना. ये डाउट जो बोल रहा है ना, पहले हाउ टू गिव एन एंट्री यू लर्न, देन व्हाई डू यू गिव एन एंट्री यू विल अंडरस्टैंड स्लोली. देखो गाइस, यस के बाद डॉलर है, ए बी के बाद डॉलर है, एंड कैपिटल ए विल डिराइव नथिंग. एप्सिलॉन means that capital B can give small b now. But how do you understand after capital A will give small b? When you compute that, substitute A with epsilon, so that this epsilon will allow us to go to follow of A and A on B, that production, that epsilon you put, you will get B as a follower. समझ में आया? नहीं आएगा. First you should know why do you make an, how do you give an entry. बाद में when you understand the parsing, you are going very advanced. We are going very advanced. First learn how to make an entry. We are building a table. We are not running algorithm. While running the algorithm, we will understand we have two entries now. A comma B an entry. A comma B, A comma dollar. We must give null productions, null roles. But null roles, it's epsilon. Why do you worry about this? If you confuse, it is just A derives epsilon. A derives epsilon is required when the first of A is having epsilon. You put it so that you will see the B as a follower. A can also give a B, but how? Not from A. It is after A. After A. That is the meaning. How capital A can give a B? When you substitute A with epsilon. A with epsilon. That means the S is looking for small b. S is looking for small b. But what capital A says? Okay, A, it is epsilon, so that you will get a B here. That is the meaning of A on B, you will have epsilon. From A, when you put epsilon, A follower is a B. That is the meaning. That is the meaning. क्यों समझने के लिए कोशिश कर रहा है? मैं ऑलरेडी बता रहा हूं. The parsing is going to help you. Some people are very advanced, and that is why we don't understand most of the things. Sometimes what is the first, then how, then later why. So why questions can be erased slowly, guys. What is LL1 grammar? Understand. How to construct the table? Understand. Why we have that table? You will understand slowly. Yeah. ये कॉन्सेप्ट समझ में आएगा जब पार्सिंग की कॉन्सेप्ट पता है. अभी तो एल्गोरिथम मालूम नहीं है ना. When we are going to do leftmost derivation, then you will understand how these entries will help you. Why we made the follow entry there, right? A comma B, we require null productions, and look at very carefully. All of them we are just giving null entries. But null entries sometimes that is AB, sometimes epsilon. Remember that. Null entries are 3. This is also null. Remember that. Null, no need to be epsilon. Indirectly or directly, that is null. Yes. So always, look at all red marking. Look at all red marking. I have made entry using red marking. This is epsilon, epsilon. Look at that. Only 4 entries I have given. 1, 2, 3, 4. That's all. Why did you get them? Because of the follow set. Why do you want follow? Because first has nothing to do. When first has nothing to do, it's very simple. You are studying a textbook. Textbook से समझने आ रहा है. But textbook के बाद जाना है कहीं पर. That after textbook, you need to ask the faculty. You need to search on the Google. That is the follow of the textbook. Yeah, समझ ले यार. This is required in future, not now. Alright, chalo. Then table. Table construction nahi aata, right? So you are going further. How to make an entry, understand, not why to give an entry. Both are different here. Okay. S, A, B. And A, B, C is not there. Dollar. And now how to make an entry. Again, I am explaining. And first focus on first only. Don't focus on follow set. First focus on the first only. S comma A, S comma B, A comma A, B comma B. After that, for epsilons, we do specially S comma dollar, A comma B, A comma dollar, B comma dollar. This entries comes later. So first focus on first set. S comma A. Who gives A? Who gives A, guys? This gives A, but also the small a can also come here. So both are reasons now. Both are reasons. 2 entries will come here, guys. S derives AB and S derives A. Both productions can derive A as the first terminal. Everybody, small a. And anybody else? Just only 2 productions are there. So maximum 2. And A comma B. Now focus on B. And ये तो B कभी नहीं आएगा. इससे B कैसे आएगा? When you put epsilon here, that small b can come here. Yes, this is only can give. That is S derives AB. You can write just RHS. You don't need to write everything. Now multiple entry. अगर exam में पूछ रहा है, so is it LL1 or not? Directly not LL1. पूरा करना जरूरत ही नहीं है आपको. You can stop here. You can say it is not LL1. आपको LL1 table नहीं आएगा अभी. But we are following it. Now ये हो गया ना? ये हो गया, B हो गया. Now come to A. ये comma A. ये कामा ये मतलब ए के लिए 2 प्रोडक्शन है गाइस. ये के लिए 2 प्रोडक्शन है. ये एप्सिलॉन कभी ये स्मॉल ए कभी नहीं आएगा ना. तो ओनली दैट इज ए डिराइव स्मॉल ए कैपिटल ए. एंड द नेक्स्ट ये भी हो गया. नेक्स्ट बी कामा स्मॉल बी. देयर आर 2 प्रोडक्शंस फॉर द कैपिटल बी. एंड हु गिव्स अ स्मॉल बी? ओनली बी बी. सो वी विल राइट बी डिराइव्स बी कैपिटल बी. नाउ दिस इज ओवर अबाउट द फर्स्ट सेट. First set is visible, so you did it. But follow set is when the first can't do anything, then you look at who is after that. S comma dollar. S comma dollar. So S की null production कौन है? This is the null. Indirect null, guys. How do you know that is null? Because capital A is epsilon, capital B epsilon, then you get null production. So here S derives AB. And next one, okay, that is null entry. Null entry, guys. Null entry, I am using red marking. Red marking. Why I am going for that? Because this gives epsilon. That capital AB gives epsilon. Now next, A comma. 1 is over. A comma B. A comma B. A comma B. The who is the null? That is this epsilon. So A comma B, we will have A derives epsilon. When you have a null production, it's very easy to give entry. A comma dollar. Null production. B comma dollar, B comma dollar, null production. But be careful, sometimes you should be very careful. Yes, derives AB is there, epsilon is there. Then follow set में if suppose follow of S is dollar, then dollar के अंदर अगर A to epsilon है, B to epsilon है, then yes, on dollar you will have both productions, guys, because both are null productions. This is also null, this is also null. So follow set, we will only give null productions. We don't look at anybody else. So this is why null productions are required. Clear this point? Come on, quick. Everybody, and those people who are just blindly calculating everything, it's not going to work in the exam. It's not going to work. Yeah, if I say, is it LL1 grammar or not? You can easily answer in the first entry itself. Okay, so given grammar, I can say now, given grammar is not LL1. Given CFG is not LL1. Okay guys, so I'm going to complete something. This table construction you do as homework. Table construction, which is first you compute first set. If you see any epsilon in any first set, then you compute the follow set for that non-terminal. After that, first make entries using the first set. Don't go to the follow set now. First make entries using the first set except epsilon combination. Then because of epsilon we go to the follow set, and for every combination in the follow set we give null productions as an entry. Null productions. And also remember guys, if you have S row, you will have only here S productions. Never look at A productions. If this is A row, you will have only A productions here. Don't look at here and there. Only S productions are responsible. Here something X is there. It means the entry, what production? It means that find S production that derives X as the first symbol. That is the meaning. So you need to find out every production that derives X as the first symbol. Agar ek bhi miss hua na, to your answer is wrong. Okay, this is what we have done. And follow set is completely different. When you are looking at the follow set, you only give null productions. When we are looking at follow set combinations, we will make null productions entries. Make null productions. Make null productions as entry into table. Null productions are very special. Maybe they are direct or indirect. Guys, tomorrow in the next class we will see how to identify LL1 grammar. But you can apply the theoretical knowledge. Sometimes you may succeed. You can construct the table, but it takes much time. We have the shortcut to identify LL1 grammar. So tomorrow we are going to learn. Then we will identify LL1 grammars. We will practice tomorrow. And then we will look at what is LL1 parser. Here you can ask the question, why do you require the dollar? And why do you make such entries? You will understand here clearly. So I'm going to explain how to understand the algorithm prediction match. And I have taken already a table to understand. And tomorrow we are going to see that, guys. Today we have understood what is LL1 grammar, that's all. And how to construct the table, that's all. But what is LL1 parser still left. Construction of table, and we have lot to learn in the future. All your doubts will be answered one after other, and keep the questions right on the paper. Why do you require the dollar at the end of the input? And you will be answered when you are looking at an algorithm. Okay, see you guys, and please follow me on Unacademy. If you are not knowing about Unacademy, you just visit and know about it. You will understand how the Unacademy delivers the lectures to you. All right, and you can follow. There are very good sessions on this channel. You can follow other educators to learn the courses. And thank you so much. Use DEVALIVE if you are coming to Unacademy. I will help you to crack the GATE exam. And please like the button or click on like button, and please do like the session every time you attend, and share and also subscribe. Thank you so much for attending this session. See you guys. Bye bye. Take care.